Now let's try to summarize the techniques that we have learned to solve this sort of an integral, right? There are like basically three categories that we have done so far. Okay, the first case was when the power of at least one of these terms are odd. Say for example, if cosine x has a odd power, that means if n is odd, right? Now if I take a explicit example, let's have it as sine to the power 10x and cosine to the power 15x, right? So the power of the cosine is odd. So we actually now, if one of these two terms has an odd power, then we don't mind about the nature of the power of the remaining term, right? It's okay for it to be even or odd, but still we carry out the same sort of a calculation, right? So if one is odd, let's take that like if we consider a particular case where the power of cosine x is odd, then what we should do is we take one cosine x term from this whole thing. What I mean by that is we write the same thing, sine to the power 10x, and we extract out a single cosine x term from this bulk, right? So we will remain with cosine 14x and with the additional cosine x term that we extracted out, right? So we are doing that extraction from the trigonometric identity where it has an odd power, right? Say if both of these terms has an odd power, then we can randomly choose one out of these two, right? Okay, so once this extraction is done, we have an even power for the remaining cosine term, right? Then as it is an even power, what we can do is we can write it as cos squared 2x to the power 7. So constructing this cos squared term was the main goal. Okay, then once you have constructed the cos squared term, we have the trigonometric identity where we can write 1 minus sine squared x as the cos squared term, and all these remaining powers will come along, will be tagged along, right? Now see, we have converted our equation or the original problem in terms of sine and cosine, but the important thing here is when you are doing the differentiation, you have a cos x dx term, right? Therefore, if you are substituting for sine x, remember I mentioned if you are substituting for sine x, you must have a cos x dx term, right? So that's the very important key idea in this calculation, right? So this was our target, and the reason for choosing an odd power is once a term from this bulk is extracted out, you will remain with an even power. So since it is even, you can write it as squared to a certain power, right? And this squared x term, the squared of the trigonometric term, can be converted with the famous trigonometric identity, and as you then you will have the end result like this. Okay, and with this substitution, you can easily compute out the integral. And even if you have the odd power for sin x, you should do more or less the same thing. Now let's say if m is odd, right, then you have to do everything in a very similar way, but these substitutions will be interchanged, right? Say if we have sine 15x times cosine 10x, then this is the odd power. Hence, we extract out sine term from the odd powered trigonometric identity. So when it is extracted, it becomes sine 14 cos 10, and I am writing that extracted sine term at the end, because that's the place where we write the dx term, right? So since this is even, we can write it as sine squared to a certain power, and sine squared can be written as 1 minus cosine squared x. Okay, then everything will be in cosine except for this one. But if you are using the substitution for cosine, you must have that sin x dx term towards the end, right? When you are using the substitution for cosine x, you must have this term for the substitution to work properly. Okay, right. But now what will happen if both have odd powers? Let's say cosine 15x, sine 15x. What should we do when we have this sort of a case? Then we can, like, I will change this to 17. So they are two different odd powers. This is 17. Okay, so what we can still do the same thing, but you can randomly choose one out of these two terms for this similar calculation. Okay, then the remaining term, now let's say for instance if we choose this one for the alteration, then cos 15 will tag along the calculation throughout this way, right? So it will be cosine 15x, and this sine 17x will be changed according to the way I explained. Okay, but still you will have to do the same procedure, right? And then the next one is, what will happen if none of these two terms are of odd powers? Like, what if both sine and cosine terms are having even powers? Like this. Right? If both have even powers, then we will not be able to use the trigonometric identity of sine squared x plus cos squared x is equal to 1. Then we will not be able to use this trigonometric identity if both have even powers. Then in that case, we should use the half angle formula or the double angle formula. So with the double angle formula, we just have to substitute it accordingly, like sine squared x and cos squared is given by this formula. So what we can do is, since these are even powers, we can rewrite it as cos squared to the power something and sine squared to the related power, right? And for this cos squared and sine squared term, you can use these two portions, right? And then we can carry out the simplification. Now of course, since these are larger powers, it's not that easy to do the simplification, but if these powers are like small, if they are small, then you will be able to do the computation easily. And I think you got the idea from the previous video that I did. Okay, and now in the next video we will see how we are going to use, like there will be a similar method when we have tangent and secant powers, right? Tangent and